The session 1 has ended with very knowledgeous and informative session. It is there. Now I want to invite Dr. Shivanti Shaha Madam to start the second session. So let's introduce Dr. Shivanti Shaha Madam. Um, she received BTech degree from in Electronics and Communication Engineering from University of Kalyani in 2002, and MTech degree in Electronics and Electrical Communication Engineering with specialization in Telecommunication System Engineering from IIT Kharagpur in 2006. She has obtained her PhD degree from IIT Kharagpur in 2014 in the area of wireless communication. Presently, she is working as an associate professor at National Institute of Technology Patna or NIT Patna since 2013. Her primary research interest includes detection and estimation of physical layer issues of wireless communication, application of machine learning, deep learning in communication, V2X communication, unmanned aerial vehicle communication, cognitive radio network, full duplex communication, 5G, 6G radio, detection and estimation theory, IoT, etc. She has many papers in reputed journals and international conferences. She is the principal investigator of couple of projects. She has guided and guiding couple of PhD students. Dr. Saha is a member of IEEE and lifetime member of INRASS, URSI. She serves as a reviewer of internationally reputed journals such as IEEE, Elsevier, Springer. Today, our research topic is mainly focused on 6G communication. So, over to you, ma'am, for this session. We are heartily waiting for your session also. Enable technologies for 6G communication. The topic is. Please, over to you, ma'am.
Um, yes. Thank you, Pradipta sir, for the nice introduction. And am I audible to all of you?
Yes, ma'am, you are audible.
Okay. And a very good evening to all the dear participants. So it's a late hour at the evening after a busy day. So I hope that you will stay with me, and I will share you some of my knowledge which I have gathered in 6G communications with you. And it was nice that Devjani madam has already founded already laid the foundations about various technologies which has been introduced in 5G. And basically, depending on those technologies, we are advancing towards the 6G communications. So I will try, because 6G communications, the concept is a newer one to all of us nowadays, and the research has just been started in various domains of 6G communications. So I will try to give you a holistic view of 6G communications, its vision, its use cases, the enabling technologies, the requirements, the limitations. So these will be covered. I have tried covering it through my PPT. So I really wish that will be useful to you also. And just I'm sharing my PPT. Is the PPT visible?
Yes, ma'am. It is visible now.
I am doing it full screen, and then I will change it. You please check it and tell me whether the PPT is changing or not.
Okay.
So it is full screen now. I am changing it. Is it changing?
Yes, ma'am. It has changed. It is a now full screen.
A full screen, and the PPT is changed. Means
Yes.
now I am in slides are changing.
Yes, ma'am. Yes, ma'am. It is changing.
Okay.
Okay.
Okay. If you find that it is not changing, please interrupt me.
Okay.
So so let's start our discussion. That is the 6G, the next frontier, vision, roadmaps, and technologies. So in short, if I want to tell what is 6G, so 6G it's not one technology. This is 6G. We cannot tell like that. That is same about 5G also. So we had seen that 5G is having many verticals and many use cases. So like that, 6G is also is we can say that is a convergence of many technologies. Basically, it is a convergence of ubiquitous communication, seamless communication from terrestrial to non-terrestrial to the underwater communication, along with inclusion of cloud, edge computing, and fog computing. And the last one is, and which is the very important one, that is inclusion, the use of AI. So it's altogether a very is a convergence of AI based techniques, seamless connections from non-terrestrial to terrestrial networks, distributed computing in in cloud, fog, and edge, and internet of almost everything. So if we integrate all those things all together, we may have an understanding that what 6G technologies are. So from that introduction, I like to start the presentation. So it's being told now that 6G, that is the road to a global brain. In 1926, Nikola Tesla was stated that when wireless is perfectly applied, the term perfectly is very important. That is everywhere. Now, it is not wired at all. It is wireless everywhere. If the wireless is perfectly applied, the whole earth will be converted into a huge brain. So we can visualize 6G like that. So it's a very conceptual thing that how we can visualize 6G. So the world is now at a stage that by 2030, various standardization bodies are aiming that they may have some standards or some technologies of 6G with us. So by 2030, responding to fundamental human and social needs and based on the expected progress in ICT, information and communication technology, Tesla's prophecy may become a reality through 6G technologies. We may say like that. Basically, what we had in 5G, ma'am has already described it to you, that we are having IoT, we are having digital twins, and various use cases of 5G like EMBB, URLLC, MMTC, etc. in 5G. Now, so on top of that, we are building our empire of 6G. We can say like that. The Huawei nowadays has recently proposed 3 additional application scenarios in vision of 5.5G. That is, they have already proposed those solutions. So we are already progressed towards beyond 5G, we can say. And all the developed countries or the power centers in the world, like USA, European Union, China, they have all recently funded the 6G projects with the common goal of enabling connected intelligence. So 6G, we can say, that is nothing but a connected intelligence. Everything is connected through wireless and intelligently. So we can define 6G that way also. Besides the ITU, that is the ITU already have published the system requirements and driving characteristics for Network 2030, which is going to be a initial step of 6G communications. And we see that with 6G, it is expected that 6G will go beyond the mobile internet to support ubiquitous artificial intelligence services and internet of everything. That everything term is very important. So 6G, I have already told, that is wirelessly connected intelligent world. And that connection is a ubiquitous connection from non-terrestrial to terrestrial to underwater networks. And there is a huge application of AI-based technologies in the upcoming 6G network. And we can see that the areas where the 6G technologies will be deployed, that is sustainable cities, connected autonomous systems like connected autonomous vehicles, brain-computer interfaces, digital twins. Another very important and interesting application, that is tactile and haptic internet. High fidelity holographic society, extended reality, and of course the metaverse. So this is the new world of 6G, which from this point of view we may see that it is something which whether we are going to achieve or not. So 4G and 5G has started addressing such challenges, but we are just at the beginning now. So already we have started our journey from 4G and 5G. 5G has already, we are having augmented and virtual reality. Digital twin technology has already been developed. We are already getting more than 100 Gbps data rate. We have already achieved it. That is the 1 Gbps data rate. 100 times greater connectivity, 100 times the number of the devices to be connected is 100 times than the 4G. Very low latency of less than 1 milliseconds. So already those challenges have already been achieved in 5G. And that laid the stone for the 6G communications. And we had seen that already the edge computing, fog computing, and the AI are playing a very vital role in 5G communications. And from there, our journey begins for 6G. So 6G will provide an ICT infrastructure that enables end users to perceive themselves as surrounded by huge artificial brain, offering virtually zero latency services. Zero means it is in the order of nanosecond, maybe. Unlimited storage, and no, it's not nanosecond, in the order of less than 0.01 millisecond. Unlimited storage and immense augmented cognition capabilities. So 6G will not only connect the earth, but also close the proximity of sky too. So this is our 6G vision. If we want to see it, so what is our requirement? Reliability. That comes into the picture right now, because we are going to use it in very crucial application like autonomous vehicle, like remote surgery, which is a question of life and death. If there is some mistake, if the network is being hacked, so the reliability is a major concern. Data rate, which we are now targeting, that is 1 Tbps. In 5G, it was 100 Gbps. Now we are targeting for 1 Tbps. Latency less than 1 millisecond. Basically, it was there in 5G, it is even less. Mobility, that is the Doppler and all, could be addressed for 1000 km per hour. Frequency in the terahertz frequency range is going to be used as it offers a greater bandwidth and data rate. Massive scale connectivity. So these are the requirements for 6G. And we see that we will not be confined with the sub 6 GHz band now. Rather, we will shift us to millimeter wave communications and terahertz communications. We had already noticed that millimeter wave communication is not a big success for 5G. So in 6G, we are targeting that maybe the millimeter wave application, millimeter wave technologies could be deployed successfully in 6G. In terahertz band also, we are attempting to integrate visual light communication or optical wireless communication, which works in terahertz range and which will give us immense bandwidth and data rate. The other technologies are meta surfaces, tactile internet. Already I have told optical wireless communication, backscatter communication, drone-based communication, and of course, the distributed edge computing and AI. And what are the application areas? That is for tracking, for AI-based application, for virtual reality, augmented reality, and extended reality, for wearable devices, for smart transportation, for smart cities, for wireless data sensors, and for e-health, and many more. Basically, everything is going to be connected, is expected to be connected through 6G. That is the vision of 6G. Now we will discuss what are the sustainability issues for beyond 5G. That is what we observe today. That is, we are having coverage issues. The 3.5 billion people are there without wireless internet. We are having network holes, coverage holes. 6G, what 6G is targeting? There will be no coverage hole network, as it will be seamlessly connected with terrestrial and non-terrestrial network. So there will be no coverage hole. Energy sustainability in hyper-connected society. We are seeing that as many as devices are going to be connected, the energy usage is skyrocketing. So we have to minimize the energy also. With 6G, it is expected to enhance the energy need even more. So we have to adopt, and that is a criteria that we have to adopt the technologies which will be very, very energy efficient and that will consume very low energy. EMF raising concerns. What impact? I am telling that everything will be everything, IoE, Internet of everything will be wirelessly connected. So what will be the impact, RF impact on human brain, on the physiological processes? So how to decrease the exposure? human centricity and trust, data control and governance, security and autonomy. Those are the few other issues. So these sustainability issues will always be there with the advanced next wave technologies, as this FDP name suggests. But we have to devise the solution of it all, the solution of it as well. We know that every invention is having some disadvantages with it, but we have to sort it out and we have to resolve it eventually. Now, why we need a new generation? Because we are already having 5G. So in 5G, we have developed new technologies. So we are already ready with various new technologies. That is, we are having a technology readiness. And we are coming up and we come up with the new services, application, and use cases. So when we are integrating these two, our technology readiness and the new applications, new services, we are getting a next generation of the network, that is 6G. So what is that? We are having, already I have told, the communication satellite integrated with the terrestrial network, even with the underwater network. We are having human computer interface. We have already developed deep learning, machine learning based techniques. AI has been already developed. We are with us various distributed computing techniques like cloud, from cloud to fog to edge. Not only edge, after that we are having tiny ML. That is, the computing will be done itself in the IoT devices. So the computing has been distributed now in 4 steps, from cloud to edge, cloud to fog to edge to the IoT devices. And we are having new applications like holographic communication, tactile internet. That ma'am has told already, Devjani ma'am. That is, we are integrating 6 sense in the communication. And when we are integrating it, the next generation, the new wave of communication we are having with us, that is 6G. So it's not, 6G is not a dream. We are ready with the technology and we are developing the applications. When two will be integrated, we will get some aspects of 6G with us. And ITU also planning to have something by 2030. Maybe you people know that for 5G, all the countries have set a goal that 2025 they will have some 5G standards, and we have already had it. Now the next goal is 2030, and there the technology which the generation we are going to get, that is 6G communication. So what is that 6G? As I have already told, and repeatedly I'm telling, that is total convergence of technology, which maybe we think that is a utopia, not a reality, but it's not like that, because technology readiness is there. We have developed some of the technologies already. So we have to integrate it. If we can, we may have the 6G. So now we can see the physical world, the digital world, and the human world. Everything will be connected. By what? By twining, that is digital twining and control, cognition and syncing, and real-time control. So if we can do it, that total convergence will give us a new generation, that is 6G. So that is the technology which are being integrated. You may see this is a very it's a beautiful diagram, you may say. That is, already with 5G we are having machine type communication, but now with 6G we are going to having ultra massive MMTC. MMTC was there, but we are now getting ultra massive MMTC. Super immersive, as we are having internet of holograms, augmented reality, extended reality. Super precision, in case of industry 4, that is industrial automation, V2X communication, the network of autonomous vehicle, tactile internet. Super URLLC. We are having URLLC already. So URLLC use telemedicine. Now with 6G, we are going to have super URLLC, that is ultra reliable low latency network. And of course, that is a use case are healthcare, because there we need the extreme reliable application.
Hello.
Yes.
Hello.
Yes.
Yes.
Somebody is saying something. Hello.
No.
Am I
She is
audible?
muted.
Achha, okay. So ultra reliable low latency communication. The use case is the telesurgery, healthcare, etc. We are already having EMBB, that is extreme mobile broadband. Now with 6G, we are going to have super EMBB. That is, the user experience is going to uplift it to altogether to a next level. We are having 4K vision. There we will get going to get 8K vision, super resolution, video surveillance monitoring. So these are the use cases. And the intelligence, that is self-driving, UAV, smart homes, already it was there, but more and more number of devices will be connected through it. So the use cases which we are having in 5G, they are going to get, that is more number of devices with a better user experience. We are going to have with 6G progression. Now, for your understanding, some examples of beyond 5G application. That is 5 senses interactive hologram technology. I will show you a very interesting video about the holographic communication also. Interactive haptic communications, that is touch-based communication. That is very much important for robotic surgery. That is whether the surgery will be done in a remote place by the surgeon, and the touch signal will be communicated through the internet, and the robot will do the surgery. So these are the applications of 6G. And for that, we need to have microsecond to millisecond latency, self-designing joint C4. There it is, we call it C4, communication, computing, caching, and control. So these are the new feature for 6G. Ultra high capacity and deterministic network optimization. Few more examples. That is 6G V2X. Vehicle to everything, vehicle to anything communication. This is for the next generation autonomous vehicle. So we have already the companies, the automobile companies are developing the autonomous vehicles. We are already having the Tesla with us. Now the experience is going to in the next generation. We will have programmable V2X environment, quantum computing, tactile communication, brain-vehicle interfacing. That is brain-vehicle interfacing. Really, it is an interesting feature. If the driver is feeling drowsy, or he or she is exhausted, she is unmindful, so it could be detected. So it could be useful for to avoid many accidents. Blockchain-based V2X, blockchain, that is for the security issues, which is a very crucial one for autonomous vehicle. Terahertz assisted V2X networks, because we need to have a very high data rate and low latency communication. So here, optical wireless communication, visible light communications, they are going to be used. Machine learning, that is the another player in this field. And the enabling technologies in the which are the enabling technologies? RF VLC V2X system, that is radio frequency and visible light communication, integration of these two. Large scale non-orthogonal multiple access technologies, multiple radio access technologies, advanced resource allocation, new multi-carrier schemes. We are having WebDM, In 4G, the game changer was WebDM, orthogonal frequency division multiplexing, that is a multi-carrier scheme. In 5G, we are having non-orthogonal multiple carrier. Now, for this, for V2X, 6G V2X, we need to have new multi-carrier schemes. UAV satellite, UAV is, that is a high altitude platform, and the satellite assisted, that I have already told, that is integration of non-terrestrial and terrestrial network. That is going to be a game changer in 6G. Integrated sensing, ma'am has told, the integrated joint sensing and communication, that is another aspect of 6G communication. So integrated sensing, computing and communication. So it is not only integrated joint sensing and communication, it is integrated sensing, computing and communication. And this computing will be extremely distributed from cloud to the user device. Another example, remote surgery. That is, you can see, that is the use of tactile internet, and video, audio, text, and tactile feed will be communicated to it. So the doctor is with the master console, and he or she will give the instructions, tactile instruction, audio, video instructions from there, and the remote robot will do the surgery. For this, the ultra reliable, low latency network is the requirement. This is the roadmap, 6G roadmap and timeline. So we are already having 3GPP release 18. Release 18 is giving the 5G evolution, which is beyond 5G. Release 16 and release 17, we are having low spectrum enhancement and wireless integration for high spectrum enhancement. 3GPP for 6G, we are still in the phase of study and specifications. Product has not been developed yet. ITU in 2018 and 19, so you can see that 3GPP, 5GPP, ITU, collaborative research, they are the different bodies which are in this process of making the standards and the product for various wireless technologies. ITU, they're having 6G vision up to 22. Now they have identified the 6G requirement. Now there is the stage of 6G evaluation. There is the collaborative research in European unions. They're doing the unconstrained R&D. I will give you some example of a research lab from CEA Leti in France, who are doing many research on 6G communications. And they're in the process of making the 6G test beds as well. So this is you can say that how the various standardization bodies are heading towards generation of 6G. These are the key KPIs. KPI is the new term which is being coined nowadays, that is key performance indicators. So we can see that KPIs for 5G was 10 megabits per second per meter square traffic capacity, which is going to have in 6G 1 to 10 Gbps. Data rates for download 20 Gbps, where in 6G they're targeting towards 1 Tbps. Data rate uplink 10 Gbps, where in 6G it is going to have 1 Tbps. Uniform user experience 50 Mbps 2D everywhere, 10 Gbps 3D everywhere. Latency up to 1 millisecond, up to 0.1 millisecond, just I have told. Jitter, it has been not addressed in 5G. This is up to 1 microsecond. Communication reliability, that is, the communication reliability could be checked by bit error rate. So in 5G, the bit error rate, the reliability was achieved 10 to the power minus 5. That is, 1 in 10 to the power 5 bits could be in error. But 6G is targeting to extremely reliable communication. That is, 1 in 10 to the power 9 bits will be in error. So we need to have many security protocols to employ, very much authentication protocol to be employed in 6G to achieve this kind of bit error rate. energy per bit, picojoule per bit. That is, it is a very energy efficient one. This is going to be, or has to be a very energy efficient one to stop, because whenever the world is connected through the internet, you may see that how many devices could be connected and how much energy is needed for that. So you need to constrain the usage of energy per device to picojoule per bit. And localization precision, which was 10 centimeter in 2D, 5G was not targeting for 3G, whereas in 1 centimeter on 3D by using various intelligent techniques. As I am telling that is, the energy is a crucial thing here. So data will consume 20% of world's energy. But you know, that is, the whole world is in energy crisis now. So where to get that much energy? So we may develop the 6G protocols, 6G technology, 6G applications, but we need to take into consideration the energy constraints also. So 9 billion of connected people on Earth, 1 trillion of connected devices, wireless communications and AI assistance will be commodity. The cyber and physical space fusion turn humans, things, and events into information. All are information. Myself, my ambience, all other devices, all are information. Nothing but the information. Because you will see through 6G, whenever we are communicating, suppose I am communicating with my friend, my holographic image will be there when he or she want to talk with me. So it's not that my voice, my audio, my video, my data will be communicated. Rather, my holographic image that will be there. So myself is the information. So myself, my ambience, all the devices I am using, everything that is be a part of this information world. So this is the current trend, which cannot be sustainable. Cannot be. Because energy, we are already starving for energy. So no more energy we cannot provide. So what we have to do, we have to curb the energy usage somehow. So that is the sustainable growth. We can see the red line. And there is a MIT Technological Review on June 2019. It told training a single AI model can emit as much carbon as 5 cars in their lifetime. Because why it is telling that? It is telling like that AI model training does not emit carbon, but the energy, because when nowadays who are doing research on deep learning, you may see that maybe sometimes to learn a model, a deep learning model, it may need with a very GPU enabled processor, it may need 1 week time to give a result. So how much computing is needed for that, and what is the energy usage? So if you relate the energy, because energy we are getting from the carbon for the fossil fuel. So we can see that if more energy is needed, that is a more fossil fuel is going to be exhausted, and that increases the carbon footprint. So this way, it could be told that training a single AI model can emit as much carbon as 5 cars in their lifetime. So anyhow, we have to reduce the energy usage. So that is one constraint which we are going to have for the deployment of 6G technologies. So this is the target in to reduce the energy usage this way. That is 100x from if 2020 5G was first deployed. From that, by 2040, it must be reduced 100 times. And this is the 6G target performance, 6G 2035 societal needs. So target is capacity 1000 times from 5G, I'm telling. 100 time data rate divided by 10 latency, from 10 to 1000 times reliability depending on the application. Positioning accuracy, that is from 5G accuracy, it is from by 100, the accuracy should be even, positioning accuracy is much less. Sensor battery life to the infinity, because we are all sensor enabled, everything will be sensor enabled. So battery lifetime will be, no, infinity means it will never end, or it could harvest itself. The energy could be harvested. Connection density 10 times. But what is the societal need? That is energy. For that, we must have energy efficiency, EMF, that is electromagnetic field awareness, digital inclusion and society 5, resilience, security, low end-to-end environmental impact. So these are the societal needs which we have to meet up. Both the things we have to meet up. That is target we have to meet up, but we must not forget that what are the societal needs also. Then only the next generation communication which we are going to propose, we are going to develop, will be a successful one. So now the trade-off is between the performance to societal requirement. And always we have to keep in mind that for the system design purposes, how the requirement, this trade-off would be achieved. Now some assumptions on 6G. Two or three very important and technologies which is going to reign the evolution of 6G. One is artificial intelligence, will dominate it. That is the delivery area in the core and the edges of the networks. Fruition area, devices like smartphone and the things I have already told. That is from the cloud to fog to edge to the user device. And we call it a super IoT. Next is extended reality. The technology support for it is still unclear. Visual ambience, super contact lenses, holograms, etc., etc. So on these, the huge research is going on. If somebody is going to give some the paradigm shifting research, they can target this area. Smart materials might allow any surface to display information, because for displaying the holographic images, they must need some materials, some spray on which the display will be there. The holographic images could be built. Holographic projectors might become available even on mobile terminals. I am calling my friend, the holograph of my friend will appear in front of myself. And it could be, and the dream is to do it even from the mobile terminals. So maybe it is a dream, but some part of it is going to be implemented in 6G. So it will be cheaper to augment humans to become able to receive and visualize bits than augmenting any ambient to display them. So here I have just told we are also information. So our image, that is also information, and that is augmented and it is transferred to a remote location. That is, you are not sending your data, voice or video and on anything. Rather, you are being transmitted there through a holographic communication. So this is it's something very, if we want to see this, like we just think of some science fiction. So we have already seen all those kind of things. These are going to be a reality. Maybe not in 5 years, but by 2040 or 2050, we are going to get it. We are going to see it. In our lifetime only, it is going to be true. And that could be done by with advent of 6G technologies. So just for a little bit of entertainment, I want to show you, that is the hologram phones, which is, and I will show you that is some part of it somewhere in the research is already being done, is being done, is being in the hologram phones. Please see that, please see whether the video you can see that it is running or not. Pradipta sir, the video,
Yes.
you can see the video?
Yes, the video has started streaming.
Okay, okay, yes.
Yes, ma'am, it comes. It has paused again.
Yes, sir?
No. Okay. Now it is playing. No sound is coming.
So it's an interesting one, that which is showing us that how the 6G is going to be a reality in our life in near future. And what are the requirements? That is, am I audible, Pradipta sir?
Yes, ma'am, you are audible.
Okay. That is the perception of infinite capacity that we need. Infinite means huge capacity. Ultra high data rates, massive scalability to millions of devices, 3D intelligence coverage, ubiquitous consistent user experience in time and location, zero latency network, that is extremely low latency network, we had seen 0.1 millisecond, extreme low power and energy free connectivity. So these are the requirements. And vision, already we have discussed a little bit of it. And the driving factors. So driving factors, that is the enabling technologies. What are the enabling technologies? Advanced modulation and coding schemes, that is in physical layer. Advanced modulation and coding schemes. We are already having massive MIMO. Now it's extreme MIMO. There is another is cell-free massive MIMO. That is another technology. Advanced, Jenny Madam has already mentioned about reconfigurable intelligent surface. Now it is advanced RIS, that is AI powered RIS. Evolvable AI, computational holographic radio, that is holo radio, integrated joint communication, sensing, computing, and storage, terahertz communication. So these are the technologies which is we need in physical layer. In network layer, Madam has already told you that is software defined networking, network function virtualization that was there in the 5G. Now what we need? Artificial intelligence native network, security native network, digital twin network, deterministic network, not a stochastic network. We need a deterministic network, information centralized network, computing power network, integration of satellite terrestrial network. So these are few, not all, enabling technologies which are needed to make the 6G vision a reality, 6G dream a reality. And this is our journey. So in 5G, we are having MMTC, URLLC, EMBB, that is extreme mobile broadband, millions of machine type communication, massive machine type communication, ultra reliable low latency communication. And the application areas was 3D video, UHD screen, work and play in the cloud, augmented reality, industry automation, mission critical applications, self-driving car, smart city, etc., smart home, etc. Next, we are in the journey of 5.5G, where we are having EMBB, URLLC, MMTC. Along with that, some new concept, that is uplink centric broadband communication, UCBC, and RTBC, that is real time broadband communication, holographic communication, machine vision, extended reality, more precise positioning, that are going to be the part of 5.5G, which is already in development. Now, when we are in 6G, the 6G vision is going to have ultra URLLC clubbed with EDURLLC. EDURLLC is event defined URLLC, and HCS. The full form of HCS is harmonized communication and sensing. Next is MMTC clubbed with COC and UCBC. What is COC and UCBC? The full form is UCBC is uplink-centric broadband communication. COC is computation-oriented communication. And the enabling technologies are federated learning, native AI network, machine vision. Last is EMBB clubbed with CAEC and RTBC. RTBC, I have just told that it is real-time broadband communication, and CAEC is contextually agile EMBB communication. And the applications are digital twins, immersive cloud, extended reality, holographic communication. So this I want to give a clear view of our journey from 5G to 6G. What more we need to have, what more we are going to have. There are some architectural innovations introduced in 6G networks, that is efficient and low power network operations, disaggregated and virtualized RAN. That is RAN also will be in cloud and edge, and we are having virtual RAN. That is RAN is random access network. Random access network of 6G could be not random access, radio access network. It would be like 5G, but it will be virtualized. We are going to have virtual MAC and virtual PHY, that is physical layer, by digital twining. 3D network architecture, that is integration of terrestrial and non-terrestrial networks, extreme multi-connectivity by exploiting terahertz, optical wireless communication, millimeter wave, and sub-6 gigahertz. So integration of all kind of communication, terahertz communication, visible light communication, optical wireless communication, millimeter wave communication, and today's sub-6 gigahertz links. And cell-less architecture, that is cell-free architecture, which presently a cell-based architecture, we are moving towards a cell-free architecture in 6G. And these are the technical focus layer-wise. We are having application layer, network layer, MAC layer, and RF and physical layer. So in RF layer, we are going to have sub-terahertz frequency bands, advanced MIMO and backhaul, non-terrestrial and satellite networks. And this is the area of deployment. That is in indoor and local, we are going to have sub-terahertz. For urban, suburban, advanced MIMO and backhaul, and for rural and in some remote locations, non-terrestrial, that is satellite network. Already the satellite network and the satellite phones are there, and the service by Star, that is the Elon Musk company, they are going to give that connectivity in India also.
Starlink.
Yes, thank you. So that is by SpaceX, right?
Yes, ma'am.
Yes. Then in MAC layer, that is in open interface, Wi-Fi inter networking across vendors and standards, and spectrum sharing. In network level, I have already told edge for computing at massive scale. Not only that, the computing at the device itself, that is also going to be part of it. Shared infrastructure with virtualized layers, intermittent connectivity and communication. An application, AI ML based network optimization, platform for wireless service, ultra low delay tolerant latency. And that is the readiness level in various layers. The readiness level I have included that for sub-terahertz bands, the readiness level is even is low. Open interface is also in development. Shared infrastructure with virtualized layer, that is also in development. Platform for wireless service, that is also in the development process. So technology readiness or maturity level is low. And for ultra low delay tolerant latency, we have already got it through 5G. Intermittent connectivity communication, spectrum sharing, advanced MIMO and backhaul, that is already is with us. So that is a map for technology readiness, that where we are and where we are going to be. So the rightmost column, that is the readiness level, is the lowest, because we are in the developing phase of those technologies. And again, I'm repeating, that is in a the distribution, that the computing is extremely distributed in 6G. Cloud data center, then fog nodes, thousands of cloud data center, then millions of fog nodes, then millions and trillions of edge devices, and not only that, the edge devices which are connected with the IoT sensors, that are also having some kind of computing capability nowadays. So there are 4 layers: cloud, fog, edge, and then in the device level. Now 6G mega trends, there are more than 10, 15 trends maybe, but now we do not have that. Sorry, am I audible?
Yes, ma'am. Yes, ma'am. Audible.
Yeah. So trend 1, more bits, more spectrum. Trend 2, 3D spatial bandwidth and 3D coverage for intelligence support. Trend 3, new technologies, that is metamaterial, memory computing, quantum computing, etc. Trend 4, ubiquitous role of antennas and reconfigurable intelligent surfaces. Trend 5, new applications, new service classes, and new media. Trend 6, energy-free connectivity, that is wireless power transfer, wireless harvesting, zero energy radio, etc. Then C4, convergence of communication, computation, caching, and control. Trend 8, ubiquitous support of AI and the path to fully distributed intelligence. Next, breaking big data and massive small data. And 10 is network personalization, and there are many more. So first is trend 1, more bits, more spectrum. So we need to have ultra high capacity front and back haul, X haul, it is written like that. Enhanced hotspot, D2D communications. The frequency of interest that are in the sub-terahertz range, starting from 92 to 94 gigahertz and going up to 200 gigahertz. So less than 300 gigahertz range has been selected for 6G spectrum. And the major stakeholders are what are the enabling technologies are the ultra high capacity front and back haul, enhanced hotspot, and D2D communications. So for ultra high capacity back and front haul, we need to have dense massive MIMO network, cell-free network architecture, massive cloud and edge computing, enhanced broadband fixed access, casual drone-based front haul and back haul. For enhanced hotspot, kiosk for high-speed download, enhanced immersive experience, D2D communication, server farm, interchip and intra-chip communication. So this I got from CELAT website. That is a French research lab. They are doing extremely good work on 6G communications. And this is the more spectrum above 90 gigahertz. You can see there are some peaks where there are some H2O and O2 vapor, which is absorption peaks. Avoiding those peaks, we are having a good amount of we are getting a good frequency range where the communication could be possible. And the propagation issues are there, of course, because as it is in terahertz range, so beams are extremely narrow. So if there are some shadow or some obstacle, shadowing effect will be very shadowing effect. We cannot, but the signal will be completely absorbed. So an extensive research has been done on frequencies below 100 gigahertz, but not for frequencies above 100 gigahertz. The attenuation for frequencies above 100 gigahertz reaches tens of dB per kilometer. For short ranges, though, the attenuation is negligible. So for short range indoor communication, it's okay. But for outdoor communication, again, the terahertz range is not very much useful if we are in RF. And there are some slides is on some beam forming and beam steering approaches in this frequency range. But we can see that in LETI, CELAT, in 28 gigahertz, they are having 20.8 dB I gain. They are getting 32 dBi in 60 hertz, 60 gigahertz, and 33 dBi in 140 gigahertz. So issues with high directive antennas, resilience to blockage that I have already told, because signal will be absorbed if there is some blockage. Mobility management, that is Doppler issues, and beam alignment. So these are the areas where we need research contribution. So this is more depth. I think we can avoid it right now, as we are going to, in this PPT, I'm going to discuss the overall 6G communication. So I'm not going to that deep. So I'm skipping this slide. And the various modulation techniques which are being used there. So that is depicted in the slides. So more bits, more spectrum. So another alternative is not RF, that is visible light communication. So we see that on visible light communication already in 5G, people are doing lots of research. So there are many papers, there are huge number of papers on visible light communication. So on 2020, we are having visible light communication through LED bulb. Now, in 2022, digital to light, that is the micro LED 60 micrometer to the power 10 pixels architecture we are getting, digital webcam by ASIC design. Next 2024, that is the special marks in ASIC has been developed, and the data rate we are getting 20 Gbps. The 2026, we are going to get wavelength marks, that is RGB multiplexing could be done. And the target is to get 100 Gbps of data rate. And the next target is 1 Tbps by 2027. Sensors plus emitters together. Sensing array by 2 to the power 10 pix, 1-to-1 projection, and micro LED 30 micrometer 2 to the power 10 pix. So that is the research which is going on in visible light communication. So that is also a very active domain of research for the researcher to contribute. The visible light communication for 6G. What are that is developing the wavelength marks and the censored emitter itself. That is in the optical domain, in the photonics. There is a huge scope of research for to support the 6G communication. Next, we will switch to trend 2, that is 3D coverage and spatial bandwidth. So what is 6G 3D coverage? Again, I am repeating the convergence of non-terrestrial and terrestrial communication, even with underwater communication. And end-to-end resources will be dynamically orchestrated to deal with heterogeneous service requirement. So it's a convergence of RF, visible light communication, the other optical wireless communication, so that we can get a seamless connectivity from non-terrestrial to terrestrial communication. And that connectivity also could be done in an intelligent paradigm. So you see this like this, that we are having geostationary satellites and LEO satellites. CubeSat is also there. And there are some high altitude platforms like drones and aircrafts, and there is terrestrial communication. So in non-terrestrial, we are having satellites and the high altitude platforms. And already we are having terrestrial communication, terrestrial network. So 3D hyperconnectivity could be done by integrating the terrestrial and the non-terrestrial networks. And you see that quantum key distribution, etc., that will be also play a key role for giving the security in this network. So in space, the air, and the ground, they will be seamlessly connected in 6G. So the 6G handoff and roaming will be the big issue, because these satellite systems are different networks, and 6G has potentially several different standards. So handover will be for the C3 architecture. That is a very challenging area where people can do research for NTN and TN network. 3D coverage, that 3D coverage is expected to have a zero hole coverage. So nowadays with in 4G and 5G, we are having holes. That is, some areas will not be covered by the existing network. So when there is a super connectivity from terrestrial to non-terrestrial, we are targeting to have a zero hole coverage. Terrestrial headnet with macro, micro, and pico base stations. Flying base stations, which we call high altitude platforms, HAPS also. That is aerial UAV drone base stations, altitude up to several hundred meters. High altitude platforms, HAPS, floating base stations, altitude 20 kilometers. Very low Earth orbital satellites, altitude 200 to 1000 kilometers, and geostationary satellites. So these are the players in this field for the C3 connectivity, hyperconnectivity. So 4G and before, little and no integration of the network. All the networks are operating on their own. Next, in 5G, we are having a little bit of integration or partial integration. But with 6G, we are having a unified design. We are going to have a unified design and full space of terrestrial integration, irrespective of the heterogeneity of the network and the network protocols. So 6G needs to consider space and airspace from beginning in definition of new radio protocols and network architectures. And the RAN, core network and service platforms that are going to be integrated. So this is another figure which beautifully describes how that integration will look like. The radio access network in space, the space RAN, the terrestrial RAN, all will be integrated. And they're intelligently integrated, not only integrated, they will be intelligently integrated. So what we need? Full interoperability, because as there are heterogeneous multi-layer network, so we need a seamless full interoperability between the heterogeneous networks. So seamless integration with terrestrial network, full adoption of 3GPP NTN, multi-tenancy and roaming, satellite air interface that is required, different types of LEO, MEO and GEO nodes, the control and management that could be orchestrated and that could be extended to space, smart routing and efficient handover, frequency sharing and cognitive radio is needed, automated and cooperative satellite control. A network in the sky, 6G is a standard also for connecting satellites. So inter-satellite connectivity and intra-satellite connectivity, that is also a goal for 6G communication. Next is the metamaterials and RIS. So use of metamaterial based, the development of already, I think that if you give a search in IEEE, you can have more than 300, 400 papers on metamaterial based RIS. And they are in the fabrication phase also. And this RIS is going to play a very crucial role for the deployment of 6G and the localization for 6G. In-memory computing, that is another technological need for 6G communication. You see that everywhere there is some memory where the computing could be done. And we will have communication C3 or C4, communication, caching, computation, and control altogether. So the conclusion is that for P3, that is the trend 3, a new physical layer incorporating sub-terahertz bands and VLC, exploitation of ambient backscattering, which enables tiny devices to operate with no battery. That is, from the backscattering, they will harvest the energy. Exploitation of reconfigurable surfaces for connectivity and localization. A new architecture supporting nearly deterministic services, distributed security mechanisms, decentralized authentication utilizing blockchain and other quantum key distribution kind of security techniques. Innovative cryptographic techniques will be issued to achieve an effective accommodation between AI and privacy. A pervasive introduction of AI at the network edge and holistic management of C4 resources, computation caching, intelligent memories and storage, and 3D coverage. So most of beyond 6G will happen locally or in 3D. Next, the last 2-3 slides I will want to show you or share you. That is the most disruptive technology, that is the edge AI empowered integrated sensing, communication, computation, and intelligence. That is, AI is going to play a big role in this. We are having AI native communication where the various kind of data, image data, haptic information, speech signals, they are there will be AI native transmitters, and the corresponding hardware will be there, and they will be wirelessly transmitted to the AI native receiver, and the task will be performed. Next is connected intelligence, that is cloud intelligence, edge and on-drive intelligence. As I have told just a few minutes earlier, that is on-device intelligence. That is another very important aspect for 6G technologies, because we are already having cloud, fog and edge, which we don't have, that is on-device intelligence. So that is going to be a part of the upcoming 6G technology. Network sensing, for gesture and activity recognition, simultaneous localization and mapping, and augmented human sense. And these are the application scenario, smart, what not. Application scenario, I can say that is what not. Everything is the application scenario. Autonomous driving, smart healthcare, smart home, industry, IoT, smart cities, everywhere we are going to have it. And the enabling wireless techniques, that is the over-the-air computation, massive access with sporadic traffic, from space to air to ground network connectivity, utilization of RIS, and cell-free massive MIMO. So these are the wireless technologies: over-the-air computation, massive access with sporadic traffic, space-air ground integrated network, reconfigurable intelligent surface, and cell-free massive MIMO. Now, what are the societal trade-off which we need? Energy efficiency and environmental responsibility, efficient industry and agriculture, efficient public services, privacy, security, and sovereignty. Because in 4G and 5G, nowadays we can see we do not have any privacy. Our life is open to internet. Though it is taking, they're telling that no, it is secured. But if you give a search in Google, any search, then there is a recommendation system which will show you everything. Whenever you will open some newspaper and all, the ad for that devices, that commodity will come into your page. So privacy, security, that is the major concern nowadays. In this 5G, we are having already this issue with us. So we need to think more. We need to devise more. More quality time for individuals, others that cannot be predicted now, because when the technology will be deployed, we can have we may see what are the wrong adverse effects of it. Now, just the conclusion. The edge eating the cloud, distributed AI at the edge, that is the one of the key player in 6G. Efficient local data acquisition, knowledge discovery, planning and operation and management, intelligent memories and storage, distributed intelligence, joint C4, robustness against devices, fails and attacks. Next, ubiquitous 3D superconnectivity, that is integration of space, air and ground networks. New spectrum, ultra high capacity sub-terahertz communication and visible light communication. These are the two spectrums which are going to be explored. And new cooperation schemes. So that's all for now. I think that I was able to share some of my knowledge with you. Now the forum is open to you. If you have any question, please ask. Pradipta sir, are you there?
Yes, ma'am.
Hello?
Yes, ma'am. Am I audible?
Yes, you are audible. Yes.
Anybody?
So,
Any question?
but your voice is very low. I don't know.
Am I audible now? Anybody has any
Hello.
Yes, ma'am.
Hello, Pradipta sir.
Yes, yes, ma'am. Am I audible? Somebody comment.
Oh, no, you are not audible to me.
Now, am I am I
Yes.
audible?
Yes, yes, you are audible now.
Okay, okay, okay.
So I
Few
have
people are
tried to,
giving
yeah.
their very nice presentation and elaboration, madam. Somebody giving feedback. Is there any questions arises from your side? Please ask, ma'am. She is free to answer you. Is there anybody have any questions? I think